All. First of all, I want to say thank you. Thank you to the IGMA organization. Thank you to the IGMA organizers. Thank you for inviting me to give this lecture. It was an extreme honor for me to receive this invitation. And let me say, I would have liked so much to be together with you in this moment here. I would have liked very much to experience the IGME atmosphere again. But due to my health situation, I'm not able to travel any longer anywhere. I stay in Sao Paulo in Brazil, and we are separated. We are separated in space by 13,000 kilometers. We are also separated in time by almost 1 month, as this video is produced in the mid-June. But we are together virtually. So let me start my lecture, which has the title Philosophy of Mathematics, a critical and educational task. The structure of what I am going to say is simple. I have 6 points I want to talk about. I want to talk about modernity, about modern philosophies of mathematics. I want to present a performative interpretation of mathematics and tell about how this brings about an ethical challenge. Then I would present examples from the classroom and finish by talking about aporism. And the first thing is modernity. Often, very often, modernity has been described as a period of progress. The very notion of progress has been intimately connected to the whole idea of modernity. Clearly, modernity is a concept with many interpretations, but the notion of progress have made part of this. The scientific revolution, so it was told, ensured new insight in nature, progress in our conocimiento of nature, knowledge of nature. The Industrial Revolution was presented as ensuring material welfare at a large scale. Part of modernity is also the big discoveries, which initiated colonizations and, as it has been repeated recently, also a start of globalizations. And as part of the modern project, science, including mathematics, has been glorified as the engine of progress. Science has been the engine of progress, and it has been celebrated as this. Science has been celebrated, and mathematics, as part of science, has been celebrated as the motor of progress. However, we also have to remember that many other things makes part of modernity. The scientific revolution shaped a mathematics mechanical worldview. This became an efficient means for dominating not only nature, but also social phenomena. The scientific revolution brought about a technical rationality. We have to remember that the Industrial Revolution initiated an extreme exploitation of workers and their families. The working conditions get extremely problematic for many. We have to remember that colonizations became accompanied by slave trade and racist views. Some groups of people were stipulated as being superior and others as being inferior. This also makes part of modernity. And I can continue. Zygmunt Bauman published in 1989 the book Modernity and the Holocaust. And he points out that the Holocaust's terror was made possible, technically speaking, only due to modern accomplishment in science, technology, and management. The Holocaust has been interpreted as something external to modernity. Nothing has to do with the modern movement, but Bauman points out that the possibility of Holocaust is also integrated in the whole modern project. I also want to refer to genocides. The North American genocide refers to the systematic killing of indigenous population. This has been embellished as being a chapter of modern progress. And let me just make a few references. Bauman's Modernity and the Holocaust, Matley's An American Genocide, and Witch and Clark, North American Genocides, Indigenous Nations, Settler Colonialism, and International Law. It studies about genocide, and I want to highlight that genocide makes part of the modern projects. So, modernity includes deep ambiguities. This is important to have in mind. Deep ambiguities. Modernity includes wonders as well as horrors. Ambiguities of modernity has been glossed over by Eurocentric self-congratulations, by these narratives about progress. It is important to remember that science, including mathematics, is involved in wonders as well as in horrors. It encompasses the deep ambiguities of modernity. This is an extremely important point, that science, including mathematics, includes all the ambiguities of modernity. Science cannot be simply celebrated as the engine of progress. It is includes in wonders as well as in horrors. It makes part of it is included. I'm not saying that mathematics is the cause of anything, but it makes part of the ambiguities of modernity. Mathematics is involved. It's involved in formulating and applying a technical rationality in all spheres of life. Mathematics makes part of this. Mathematics makes part of the fabrication and applications of the machinery and management techniques necessary for industrialization. The whole process of making industry needs science, needs techniques, needs mathematics. Mathematics is involved in the construction of war technologies. It's important to remember this. War technologies. It was completely clear after the First World War that science becomes part of the war machinery. Mathematics is involved in establishing the economic structures for extracting human and natural resources from around the world. Mathematics is involved in establishing the technologies of global networking. Mathematics is involved. Let me just mention two more references. Both Baunbeck and Højrup has taught about mathematics. and make a collection of studies about mathematics and war. And I would like to refer to Svet's Capitalism and Arithmetic. It's a study of what took place in the Renaissance, but the point is the same. Capitalism and mathematics are closely connected. So let me summarize here. A critical philosophy of mathematics. For a critical philosophy of mathematics, it is important to consider the social complexities within which mathematics is brought into action. We have to consider the social complexities. It is important to recognize how mathematics, for the good and for the bad, is involved in all features of life. So now let me move on to point 2, modern philosophies of mathematics. First statement is mathematics is logic. Logicism tried to show that the mathematical concepts can be defined by means of logical concepts, and that mathematical theorems can be derived from logical theorems. This is the big vision, the big aim, aspiration of logicism. Logicism inspired the idea that set theory should play a crucial role in introductory mathematics education, because mathematics was founded in logic. The basic mathematical terms could be defined in logical terms. This was the vision of logicism. Mathematics is formal structures. This is the statement of formalism. Formalists identified mathematics with formal structures. Formalism, refined into structuralism, inspired the modern mathematics movement. Then there is the position mathematics is mental acts. It is intuitionism which proposed this. Intuitionism found that mathematics is mental acts that never can be represented by formal structures. Mathematics is different from formal structures. The intuitionist view on mathematics inspired Hans Freudenthal, his conception of mathematics as a human activity. And I make a reference there to the book of All Around and Me. We have explored the different philosophy, modern philosophy of mathematics, logicism, formalism, and intuitionism. I want to show a photo of Freudenthal, and also to point out limitations of the modern philosophy of mathematics. First, we will say the modern philosophy of mathematics, logicism, formalism, and intuitionism develop their ideas in all kinds of technical details. Never before have the philosophy of mathematics has been so rich of technical reflections and technical uses of reasonings. It has been very advanced, technically speaking, compared to anything previously in the philosophy of mathematics. The modern philosophy of mathematics tried to safeguard mathematical absolutism. They did it in different ways. Logicism in one way, formalism in another way. It was an if-then absolutism. Intuitionism is also, at least as it was formulated by Brouwer, based on the idea that there is one and only one mathematical truth. There's only one kind of mental constructions which lead to mathematics. My biggest concern with the modern philosophy of mathematics is that they treated mathematics as an isolated epistemic phenomenon not involved in any social political issues. They treated mathematics as isolated, as an epistemic phenomenon, a unique epistemic phenomenon, not as making part of social life. They contributed to a deification of mathematics. Mathematics became celebrated as something very particular. And let me summarize critical philosophy of mathematics. For a critical philosophy of mathematics, it is important to explore the presumptions of established philosophy of mathematics and to point out their limitations. So I fully recognize the importance of studying classic philosophy of mathematics. It's important to study the modern philosophy of mathematics, but to see their limitations. A critical philosophy of mathematics must avoid any deification of mathematics. It must recognize that mathematics can be involved in all kinds of social affairs, also of the most despicable kind of social affairs. It's possible mathematics is involved. Now I move on to a performative interpretation of mathematics. First, I will refer to a performative interpretation of language, because a performative interpretation of language inspired me for making a performative interpretation of mathematics. But we look at the performative interpretation of language. And the point is that by means of language, one is doing things, one is performing. Language is not just a simple description, it's performance. And there are many contributions to this performative interpretation of language. First, I want to refer to Ludwig Wittgenstein, who in philosophical investigation introduced the notion of language games. We are doing something, we are performing. John Austin raised the question, how to do things with words. John Searle talked about speech acts. And if we bring Wittgenstein, Austin, and Searle together, they are somehow all in the analytical philosophy tradition. Pierre Bourdieu is not. He talks about symbolic power, that symbolic system can exercise power, or power can be exercised through symbolic systems. Michel Foucault talked about discursive regimes. It's a very strong formulation he had, that truth can be discursively constructed. Bourdieu and Foucault do not belong to the analytic tradition. They are broader. They open the broader discussion of discourses and of discourse theory. Let me summarize a discourse. Of course, it's a simplification, but it's a summarizing. A discourse is an all-embracing symbolic system that formats experiences, attitudes, assumed knowledge, decisions, and actions. It forms many parts of social life. A discourse is involved in many things. A discourse forms social and political practices. A discourse forms worldviews. A discourse forms life worlds, to use a notion coined by Husserl. By the way, I use life world in a different sense, which I have written about in one of my books. And here we come to a performative interpretation of mathematics, which somehow is inspired by the discourse, the characteristic of discourses. Mathematics is an all-embracing symbolic system that formats experiences, attitudes, assumed knowledge, decisions, and actions. Mathematics forms social and political practices. Mathematics forms worldviews. Mathematics form life worlds. And I put a reference where I talk about a performative interpretation of mathematics published here in 2023. And let me go to a critical philosophy of mathematics. For a critical philosophy of mathematics, it is important to investigate how mathematics forms not only epistemic categories, but also material structures and social practices. Mathematics has a formatting power. To a critical philosophy of mathematics, it is important to explore how mathematical performatives forms worldviews and life worlds. Now we move on to an ethical challenge. And this emerges when we see the close connection between performatives and ethics. And I really want to point out that exists an intimate relationship between performatives and ethics. Performatives demand ethical reflections. And let me point out, mathematical performatives can be prizeworthy, problematic, cynical, benevolent, generous, helpful, horrific, insignificant, risky, disastrous, useful, and we could continue. Mathematical performances could have any kind of qualities. They're not neutral. They have done something by means of mathematics. And mathematical performatives can have any kind of qualities. Therefore, any mathematical performative needs to be critically addressed. This is important. This is an ethical challenge. A performative interpretation of mathematics turned ethical reflection crucial to any mathematical practice, whatever it is in research, application, or education. Ethical reflections are crucial to any mathematical practice due to the mathematical performatives. Ethics addresses the nature of mathematical performatives and their possible socio-political impacts. Ethics concerns how doing mathematics might serve particular interest and particular power structures. It is important to open the different practices related to mathematics for ethical reflections. And I want to refer to a recently published book edited by Paul Ernest, Ethics in Mathematics Education. It is crucial that the practice of mathematics education opens to ethical consideration, just as it's important that applications of mathematics open to ethical reflections, and that mathematical research opens to ethical reflections. And again, when I talk about ethical reflections, I talk about reflections which in a broad sense concerns mathematical performatives. How are they established? Which interest are they serving? What is the impact of this? It's a broad reflections of mathematical performatives. At times I've talked about the banality of mathematical expertise. Many mathematical research practices do not consider social political issues. This is simple to observe. Look at the publications from mathematical departments. There are not much reflections there in the research publication about social political issues. It's focused on mathematics. So I see many mathematical practices being in university research or other research institutions as not considering social and political issues. They locate mathematics expertise in a self-invented ethical vacuum. This is a huge problem. That mathematics research is oblivious to social political issues I refer to as the banality of mathematical expertise. The banality in the sense that it's only focused on intrinsic mathematical problems and focusing on solving mathematical issues, not considering the broad reflection of what this doing mathematics might have an impact and what is forming the practice of mathematics. I have published the paper Banality of Mathematical Expertise in 2020. So a critical philosophy of mathematics, it is important to face the ethical challenge prompted by the performative interpretation of mathematics. To a critical philosophy of mathematics, it is important to address the nature of mathematical performatives and their possible social and political impacts. It is important to address how mathematical performatives might serve particular interests and particular power structures. This is important for a critical philosophy of mathematics. So let us go to point 5, examples from the classroom. And there is a notion I want to pay particular attention to: reflective inquiries. Reflective inquiries concern the learning of mathematics as well as the learning about mathematics. This is my important point. It's not only the learning of mathematics, but also learning about mathematics. They concern an assumed mathematical absolutism. They concern socio-political features of mathematical performatives. And to engage students in reflective inquiry is a paramount of critical math education. And let me summarize with respect to critical math education. To critical mathematics education, it is important to create space for students and teachers to engage in reflective inquiries concerning the nature of mathematics and concerning the scope and impact of mathematical performatives. To critical mathematics education, it is important to face the ethical challenge in educational practices. And I'm going to refer to 4 examples with respect to the classroom. Example of mathematical performatives. I will say something about describing, about formatting, about identifying, and about warning. It's all performatives rooted in mathematics. They could be rooted in other things as well, but I talk about them as rooted in mathematics. First, I want to refer to a paper published by Nadia Kennedy. In this paper I refer to here, talk about describing. She problematized the very notion of describing together with the students. She referred to a classic example, describing my classroom. Or often he say, make a drawing of your room. Make a drawing of your room. And students make a drawing of their room. I prefer to make a drawing. The task is to make a drawing of the classroom or another public space room in the school. Because we have to remember that the vast majority of children in this world do not have a room of their own. In terms of percentage, it's a little percentage. So, and another thing, when you make descriptions of your room, the comparison easily become comparison of the rooms. If you make a description or make several descriptions of the classroom, then the comparison becomes the comparison of the descriptions of the classroom. But the point is to open the discussion of what becomes left out by a mathematical description, what becomes included, what is in fact done by a mathematical description. There are important issues for reflection related to mathematical descriptions. To what extent does a mathematical description impose a particular perspective onto what is claimed to be described? Mathematical description imposes something on what it is assumed to describe. It's not just reflecting, it's not just photoing, it's imposing ideas, imposing structures. To what extent does mathematical modeling, it's more general, or also specific, that's more particular. To what extent does mathematical modeling impose a mathematical mechanical worldview onto what becomes described or what becomes modeled? It could be a model with respect to economic structures, human relationships, workplaces, where mathematical description might turn workers into gears in a production machinery. The mathematical description forms what it is supposed to describe. And this formatting by means of mathematics in doing the description is crucial to address in reflective inquiries. Often making description of my room is used as for a student to learn about measurement, to learn about scale drawing. It's true. It could be important for the learning of mathematics. But I want to emphasize that it is also important for learning about mathematics. Example 2, I referred to the notion of formatting. It's a performative. And I want to refer to an article written by Richard Bowell. Let's just take the title of the paper, The Mathematical Formatting of Climate Change. Just think a little about this. It's a provocative title, The Mathematical Formatting of Climate Change. How could one imagine that mathematics could format climate change? Climate change is a phenomenon, physical, natural, biological phenomenon. And here you say the mathematical formatting of climate change. But let's listen to what Bowell is saying. Mathematics also formats how we interact with the climate. Through the mathematical model-based perspective prevalent in climate research, the climate is constructed in particular ways, as, for example, measurable, predictable, tactical, controllable by humans, rather like a temperature in the high-tech sensor-controlled greenhouse. He points out that by mathematical description, we somehow conceptualize climate change in a particular way. There are issues for reflections. To what extent does a mathematical formatting impose a particular way of interpreting climate changes? When we make the description by means of mathematics, we get a way of interpreting climate change, a way of seeing climate change. To what extent does the mathematical formatting create a particular way of acting with respect to climate change? This is issues for reflective inquiries. And we can reach much broader because it's not only concerned with climate change, interpreting and acting formed by mathematics. It could be with respect to any kind of environmental issues. It could be with respect to any kind of economic transactions, economic issues. It could be with respect to management and work processes. Very many features of our daily life becomes formatted by mathematics. Mathematics gives ways of interpreting the phenomena and by acting with respect to the phenomena. Then I want to move on to an example concerning identifying. Here I have referred to, or I have presented a bias index. I presented it in a book from 2023. The bias of the representation of a group of people A compared to a group of B of people in an assembly, which I call S, is referred to as the bias of A with respect to B in relation to B in the assembly S. It is defined as, and here is the definition. And we assume that A and BS is different from 0. AS refer to the group of people from A that belongs to the assembly S. And the italic is the number. BS refer to the group of people from B that belongs to the assembly S, and BS in italics is referring to the numbers. So the bias index is this multiplication of numbers with A, the number of people from S, from A belonging to S, multiplied by B, divided by A, divided by the number of people from B belonging to S. Here you can get an idea of the parameters, that the population, the subset A, the subset B, AS and BS is those part of A and B which belongs to the assembly S. My aim of formulating the bias index was to be able to address problems of representativity by means of elementary mathematics that could be handled by secondary school students. And in this book here, Critical Mathematics Education, I have shown what brought me to formulate the bias index and why it got the shape as I have just presented it. So it was very brief, I indicated it now, but the more explanation of how it was formulated and what the idea behind the bias index is presented in this book there. Now we take an example. Killed by the police. In 2017, the number of people killed by the police in Brazil was 5,179. That's a number. The distribution of killed people was 75% black people, 24% white, and 0.2% others. The Brazilian population was that year composed of 55.8% black people, and it is referred to as partos and pretos in the Brazilian classification. 43% white people and 1.1% others, indigenous people or people from Asia. The bias index, black, white, S, refers to the degree of bias between the number of black people and white people in the subdivision of people killed by the police. We can calculate the bias index It's 2.39. So there's considerably more black people relatively killed by the police than white people in Brazil. This means that the proportionality between black and white killed by police, by the number of black and white people killed by police, is 2.3 times bigger than the proportionality between black and white people in the population. It's 2.3 times bigger, the relationship in the assembly of killed by the police than in general. Now I look at the number of people killed by the military police in the Sao Paulo state. I can see my picture disturbed. Sorry. Now I made a mistake here. But I clicked away the previous slides. What we could see in the previous slide was that the number of people killed by the police, whatever black or white or Japanese or Amarelos or indigenous, decreased very much in 2018 and 19. It was due to a camera. There was a camera placed on the uniform of the police. So whatever the police was doing became registered by the camera, and the camera could not be turned off. So the introduction of the camera almost had the impact that the number of key people killed by the police in Sao Paulo state was reduced by 50%. It was a considerable reduction. It can only be related to the introduction of the camera. Then one can look at the bias index between black and white people. Did that change? I have calculated the bias index here, 2019, 20, 21, 22, 23. You can see it's almost the same except from 2001, where the number of black people killed was proportionally much bigger than the normality. But it was somehow the brutal normality of the Brazilian case that there is a 2.3, 2.6, 2 point more black people killed than white people killed by the police. Now we look at something different. The number of children, young people, and adults killed by the military police in the Sao Paulo state from 2017 to 2021. We can look at the total. We can look at the numbers for young and adults. We can see that there is reduction when the camera gets introduced. We can also look at the bias index between young people and adults. 2017, the bias index showed 6.45, many more young people relatively than adults was killed by the police. It got reduced. It's still significant, but it got reduced. It could be correlated to the camera, but it's a surprising big reduction of the bias. Still, it is significant. It's 2 or 2.35 and things like this, but it's a significant reduction from 6.45 and 4.85 to, let's say, I don't know if that's called a normal, but the normal bias index. This calls for reflections. What to think of the change of the bias index from 2019 to 2023 with respect to black and white people killed by the military police in Sao Paulo state? What to think the change of the bias index from the same years with respect to young people and adults killed by the military police? And the issue behind is, does the military police when not observed, kill relatively more black people or young people than when observed. It's a question to be raised. And there are more reflections. The bias index does not guarantee any objectivity. We have to remember this. It's a simple mathematical techniques. The bias index might hide subjective elements, for instance, associated with the ethnic classification of people. The bias index might contribute to an identification of socio-political issues to be critically addressed. So this is my point. I don't say that the bias index shows something, but it indicates something which needs reflection. It needs better statistical investigation. It needs qualitative research. And at the same time, the application of the bias index calls for a critique of mathematics itself. This is reflections related to the bias index. My fourth example is concerning warning. Lisa Stephenson and Georgia Carrari have an example concerning oil spill. In 2010, a most serious oil spill disaster took place in the Mexican Gulf at the Macondo prospect, directed by the United States of America and executed by BP. The prospective teachers were shown a map indicating the area of the Gulf that was covered by oil, showed by Lisa Stephenson and her colleague. And there were things for the prospective teachers to think of. How big is the area covered by the oil spill? It was estimated that 7,500 milliliters of oil was spilled. How could what be estimated? Here is the map that was shown to the prospective teachers. For grasping the profound risk associated with oil production, it is important to know about catastrophes that already has taken place. In Norway, strong voices have been raised against exploring new oil fields in any of the Arctic parts of Norway. There's very strong interest. In Brazil, one finds increasing number of offshore fields and environmental preoccupation are strongly voiced. We are dealing with a strong contrast between industrial interest, financial interest, and environmental interest. It's a deep contradiction. It has to do with the estimation of risks. And there are issues for reflections. Can mathematics bring warnings that could not have been formulated without mathematics? What might mathematical-based warnings tend to overlook? In what way might mathematics-based warnings reflect political, economic, industrial, environmental issues or interests? This is issues for reflection. This was my 4 examples. Now I just want to refer to people I'm inspired with. There's the Colloquium of Research in Critical Math Education. It's colloquium organized here in Brazil several times. I have been very much inspired from this colloquium. I want to show a photo of these young people engaged in critical math education. It's deeply inspiring for me. I want to refer to the EPRA group. It's a research group dedicated to inclusive mathematics education and critical math education. It's associated to the State University of Sao Paulo. It's directed by Miriam and a little bit by me also. Miriam is my wife. I want to refer to the Pataria group. It's the PhD students I am supervising or have been supervised. It has been extremely inspiring for me. And if you see, between Miriam and me, there is Tedinho, a small boy. He is in fact participating in the IGME conference in Sydney now, well, together with his parents. Let me finish by saying something about aporism. Aporia. By aporism, I refer to the conviction that attempts to solve any deeper philosophic problems, any existential life issue, and any profound ethical uncertainty will end up in an aporia. The Greek word aporia can be interpreted as lack of route forward, or deadlock, or perplexity. Critical math education and critical philosophy of mathematics and critical mathematics education. I want to mention that for critical philosophy of mathematics and for critical mathematics education, it is important to acknowledge that critique is preliminary, tentative, and open-ended. Critique is an expression of concerns and hopes, but also of uncertainties and doubts. It is important to acknowledge that aporetic situation makes part of human life. Thank you very much.